Welcome to this lecture about sensation and perception. The first thing I want to cover is the difference between sensation and perception. So sensation is the process by which we take in stimulus energy from the environment and use our sensory receptors. So this is really where we're gathering information through our sight, hearing, ears, smell, getting that information, and it's really stimulus energy. So just the stimuli coming to us, providing energy, is what sensation is. And perception is really the process in which we organize and interpret that information. So sensation is just the energy coming to us through our senses, and perception is where we organize that and make that information into something meaningful. And our brain is really what does this process. And one thing about sensation versus perception is that our perception may not always be the same as what we're actually sensing. So our brain may interpret things differently than what the actual stimulus energy from the environment is. So they're very different processes. Perception is when we make meaning out of the things that we're sensing. I want to talk a little bit about thresholds with sensation. So an absolute threshold, the concept of that, is it's a minimum stimulation to detect a particular stimulus 50% of the time. So the minimum kind of energy that comes to us for us to be able to detect it at least 50% of the time is the absolute threshold. If something is below our absolute threshold, then we don't detect it. So a good example might be something that's really quiet and so quiet that we can't hear it, but it is actually producing sound still. And then you turn it up a little bit and you start to be able to hear it at least 50% of the time. Now it's above your absolute threshold, and so it's something that you're going to detect. Along with absolute threshold is this idea of subliminal messages. So subliminal things would be things that are below our absolute threshold for conscious awareness, but that we could detect on an unconscious level. And so these are things that you may not be able to consciously know that you're hearing, but you may be gathering some of that energy or information unconsciously. The second type of threshold is a difference threshold. So this is the minimum difference between two stimuli for us to detect it 50% of the time. So a good example would be two sounds maybe that are very similar, and the difference threshold is the maximum difference that it needs to have for us to detect that they're two different tones 50% of the time. And Weber's law is that to be perceived as different, two stimuli have to differ by a constant minimum proportion. And that proportion varies depending on the sensory stimuli. So we've kind of defined how much different certain things have to be in order for us to hear them. Sensory adaptation is a concept that is the idea that we become less sensitive to stimulus that don't change over time. So if a good example would be if you wear a watch. When you first put it on, you probably notice it, but the longer you wear it, you're not consciously thinking about it. So we become less sensitive to stimuli that don't change. If something in our visual field is constant, we're probably not going to focus on it all the time, but if suddenly something moves, now we're going to focus on that. So that's the idea of sensory adaptation, that you might notice something at first, but you can become less and less sensitive to it the longer it doesn't change. A few questions just to consider with sensory adaptation are maybe some advantages of it, what could be disadvantages of sensory adaptation. So some advantages obviously could be that there's a lot of stimuli out there in the world and we can't pay attention to all of it. So it's an advantage that if something's staying the same, we don't have to constantly keep reprocessing it. So that could be an advantage from a kind of stress standpoint. We don't want to be trying to take in information from everything that we're seeing all the time. Disadvantages could be that maybe something's staying the same and we do want to pay attention to it. So we're not going to be as adapted to do that. This also has a survival function in that when we become kind of used to something or something doesn't change, we're not paying as much attention to that, but we have more attention then to focus on things that are novel. So that helps us detect threats. If something's moving or something's threatening, it's more likely to be something that's new. And so sensory adaptation is helpful for our survival. And this adaptation is different for vision than it is for hearing or smell or touch. And the reason for that is that your eyes are constantly moving. And it's a good idea. It's interesting to think about why that might be. So one thing might be that we want to be able to see everything in our environment, right? We might kind of zone out and not pay conscious attention to everything, but we don't want things to go away or for us not to be able to see them, because that wouldn't be very helpful for our survival standpoint. Vision is also the sense that we rely the most on, and so as humans we want to focus our attention on visual stimuli, and that's one reason that the adaptation is different. So we're going to talk a little bit about how we receive sensory information. So all of your senses that you normally think of, obviously, so vision, hearing, touch, which includes pain, taste, smell, and then kinesis, which is the sense of your body parts' position and their movement. Sensory interaction is another concept, and this is the concept that senses work together and influence each other. So what one sense perceives might impact how another sense perceives it. And if sensing is congruent, we may perceive what happened. If it's incongruent, we may have to adapt our perception to try and make sense of it. So a good example of this might be if you have ever tried to eat something that smells really bad, it usually tastes bad as well. But if you plug your nose, it doesn't taste nearly as bad because you can't smell it, so the taste is kind of deadened a little bit. So that's a good example of sensory interaction. So we're going to talk a little bit about each of the senses. Vision is the first sense we're going to talk about, and what vision is essentially is the eyes are receiving light energy. So it's just energy hitting our eyes. There's two kind of components of this. One is the wavelength, and the distance from one peak to another in light energy is what the wavelength is. And wavelength determines the color. So when you see orange, it's because it has a different wavelength than something that is white in terms of energy. The amplitude is the height of the light wave. So the wavelength is the distance between one peak and the next. The amplitude is the height. And the amplitude determines the intensity, so the brightness of the information that you're getting. So the way that the eye works, one part of the eye is the retina, and this is the inner surface of the eye. And this is really where information begins to be processed. The retina is comprised of rods, cones, and receptors, and they each have their own function. So rods detect black, gray, and white, so they don't detect color, they detect those grayscale colors. And the rods are useful for night or low light vision. And they're concentrated on the outer ring of your eye. So if you're thinking about your rods, they're kind of on the outer ring, so your peripheral vision. And they share connections to cells. Cones are what help us detect color. And they're most useful in good light or day. So when it's dark, your cones aren't working as well. And your cones are concentrated in the center of your eye, and they're able to detect fine detail. So they're really what we use when we're focusing on something specific, and rods are going to give us a kind of a bigger picture, but we're not going to get as much detail. And the optic nerve is what carries the neural impulses that the eye receives to the brain so that we can perceive things. So the process of getting information from the eye to the brain is first light energy enters the eye through the cornea, pupil, and lens, and then it hits the retina's outer layers. And after it hits that, it then hits the rods and cones. and our cones help us see the detail, and the rods help us see the grayscale and kind of the outer side of what we're looking at. Then chemical changes occur because we're receiving energy, and those result in neural signals. And those neural signals are sent through the optic nerve, and then they reach the brain, and our brain processes the signals that it's receiving from the eye. And that's how we perceive vision. So a couple of important terms. Feature detectors are nerve cells that are in the brain, and they respond to specific features of a stimulus. So each feature detector is for a specific purpose. It might be to respond to edges, it might be to lines, it might be to angles, but each of our feature detectors help us detect a particular type of visual stimuli. Parallel processing is where each component of a visual stimuli is assigned to a different team of nerve cells, and they're all processed at the same time. So we don't have just one place where all of this energy information goes. There's several different nerve cells processing, but they're doing it at the same time. And then our brain takes all that information and integrates it into a meaningful perception. So we take all that energy information from all of that parallel processing and make it into something that is an image. And then the third important term is blind spot. And this is the point where your optic nerve leaves the eye. And in this spot, you're blind, so you cannot perceive energy that's in your blind spot. And this part of the retina has no receptor cells, so it can't take in light energy. So now we're going to move on to hearing. And hearing is just like vision, except the ears receive sound energy. So again, it's just energy coming that is providing the stimulus for our sensation. And jostling molecules of air is what creates sound waves. And just like in vision, we have amplitude and frequency. So again, amplitude is the height of the sound waves, and with hearing, that determines how loud something's going to be. And frequency, or we called it wavelength when we were talking about vision, is the length of the waves. And in sound, the frequency determines the pitch. So low frequency waves have a low pitch, and high frequency waves have a high pitch. And the last thing is decibels, and this is how sound is measured. So we measure how loud a sound is in decibels, and just for your information, prolonged exposure to 85 or higher decibels can produce hearing loss because it damages the hair cells that receive that sound energy. So something to know when they say you don't want to go to loud concerts, you don't want anything that's over 85 decibels, because anytime you are in a situation like that, you're damaging your hair cells. So the way sound energy gets from the ear to the brain, sound waves enter through the outer ear and then move down your auditory canal. Once the waves hit the eardrum begins to vibrate. And then your middle ear transmits those vibrations to the cochlea, and the membrane begins to vibrate. So remember, this is all energy, so you're gathering energy through your ear that's causing vibrations. And then once you have your membrane vibrating, the cochlea's fluid begins to move and bends the hair cells. And the hair cells in your ear are what triggers impulses to the nerve cells. So when you damage hair cells, then you damage your body's ability to send those nerve impulses to your brain. And your auditory nerve carries the neural messages to the auditory cortex, which is in your brain. And that's how you perceive the sensation that you're getting. So hearing is interesting because we have an interesting way of locating sounds. And the way that you locate sounds is because each of your ears hears a slightly different sound. So you don't perceive that you're hearing two different sounds, but each of your ears, because of their position, receive a slightly different sound in terms of energy. And because it's the space or the different location of our ears that helps us locate sound, we're much more accurate at locating sounds when it's coming from the left or the right. We're less accurate at locating sounds when they come from the front or the back. And if you've ever done this, most people will try to do this, but this is the reason that you cock your head when you want to hear better. Because if you reposition your head, then it's easier for you to locate sound. So the next sense we'll talk about is touch. And obviously skin is the primary receptor for sensing touch. And there's 4 distinct senses that the skin can sense. The first is pressure, the second is warmth, the third is cold, and then the last is pain. And something to know about your skin, it's the largest organ on your body, and some spots on your skin have more receptors than others. So you're more sensitive on some spots of your skin than you are on others. And some spots are also more reactive to one of the 4 skin senses. So you might be more, for example, your wrist is more reactive to warmth than your elbow is. Pain is the body's way of telling you that something's wrong. And something just to kind of ponder or think about is if not feeling pain is a good thing or not. So most people don't enjoy feeling pain, but if we didn't have pain, it would be really difficult for us to know if something was wrong. So a good example, people who can't feel pain may burn their skin and harm their organs because they can't feel that it's burning. The phantom limb phenomenon is sensation from a body part that's no longer there. So this sometimes happens when people lose a portion of the limb, and they still can feel sensations even though that limb isn't there. And then the last concept on here is natural painkillers. So our bodies are hardwired to have some natural painkillers. So when we are in pain, we can deal with that on our own. And those are called endorphins. And they're produced in a couple of ways. One is by intense pain. So if you've ever heard somebody have, break a bone or something and they say, well, it didn't really hurt at first, I was kind of in shock. That's because endorphins are being released. You can also produce endorphins by doing physical exercise. So our next sense is taste. And there's 5 basic tastes. And they are sweet, sour, salty, bitter, and umami, which is a meaty taste. And there's evolutionary reasons for preferring sweet and salty tastes. So most people prefer things that are sweet or salty. And the reason for that is things that are bitter or sour are things that may have gone bad. And so from a survival standpoint, it's beneficial for us to prefer things that are sweeter and salty and not prefer things that are bitter and sour. So the way that sensory information gets from your tongue to your brain to be perceived, first of all, taste is a chemical sense. So it's different from the other senses we've talked about in that it's a chemical reaction. And what happens is food hits the taste buds and then moves to the taste receptor cells. And the receptor cells for that type of taste are activated, so you have particular receptor cells for particular types of taste. And then the messages from those receptors trigger a response in the brain's temporal lobe. A little information about the tongue, which is the way that you sense taste, is each bump on your tongue has more than 200 taste buds. So you have a lot of taste buds that can help you receive chemical information. Taste buds reproduce themselves every 1 to 2 weeks. So if you've ever burned your tongue and your taste declines for a while, usually that goes away pretty quickly, and that's because your taste buds can reproduce and heal themselves. And the last thing is, as we age, the number of taste buds in your mouth will decrease. So this is one reason that sometimes people, as they get older, start to like spicier foods or maybe foods that they didn't like before. Part of that is because you don't have as many taste buds. So the next sense we'll talk about is smell. And like taste, smell is a chemical sense. Odors are often associated with events or feelings, even if we can't name them. So smell is highly connected to memory. And if you've ever kind of smelled something and it brought up a memory, a good example might be whenever I smell fresh cut grass, I think of my husband because he cuts the grass. So that's a good example of how smell and memory are connected. Olfactory receptors produce different patterns, and that's how we identify odors. And as humans, we can detect over 10,000 odors, although we're not particularly good at discriminating between the differences. So the way sensory information gets from our nose to our brain, first of all, air molecules are inhaled into the nose. Once those molecules reach the receptors at the top of the nasal cavity, then those receptor cells wave and they respond to certain smells. And those receptors then send the messages to the brain. So now we're going to move on to some kind of perceptual concepts rather than sensation concepts. And so we're going to talk a little bit about perceptual organization. So the first thing I want to talk about is Gestalt principle. And this is the idea of integrating parts into a whole. And the idea really behind this is that things are more than just a sum of their parts. So the whole has a different meaning than the parts. So if I'm looking at a picture and I separate it into a bunch of parts, that doesn't have a lot of meaning. But if I put it into a whole, it may have a meaning not just of the parts together, but also a different meaning in terms of things I might relate it to or the way I might perceive it. The second concept is figure ground. So if you're thinking about Gestalt, figure is the thing you're focusing on. Ground is the background information. So when you're perceiving things, there's always something that's the figure, what you're focusing on, and something that's the background. And the relationship between those two things are constantly changing. And then the third concept is perceptual constancy. And this is when we perceive objects as unchanging. So we perceive that they have a constant shape or size or color. And this can lead to optical illusions. So we kind of tend to fill in information that's missing so that it will be constant or fit with something that we already know to perceive. So the next idea is grouping. And this is basically how we group things so that they can make meaning out of them. So one way we group things is proximity. So things that are closer together are things we group together. The next way we group things is continuity. So we perceive things as continuous rather than discontinuous. So if we had a line, we're going to perceive it as a continuous line, even if a little slice is missing in that. And then closure. And this is where we fill in gaps to complete the whole picture. So a good example of that might be if you saw a sentence with several of the letters missing, you could still perceive the meaning of that sentence. So now we'll talk a little bit about depth perception, and this is obviously estimating an object's distance. And the way we do this is binocular cues and monocular cues. So binocular cues are the images on each of the eyes is slightly different. So just like with hearing, our ears are hearing a slightly different thing, our eyes are also seeing a slightly different thing because of their position. And monocular cues lead us to have perceptual constancy. So a perceptual set is the mental tendencies and assumptions, so things that we already know that we use to perceive the world. And our perceptual set impacts the way that we perceive things. So when you're going about in the world, we tend to perceive things how we expect to perceive them. So if there's a small typo, this is a great example of how this works, would be if there's a typo in your paper, you're not very likely to see that because you think that it says something particular. So that's why it's better to have somebody else proofread for you. And that's the end of our presentation on sensation and perception.